Good morning, everyone. Am I audible? Am I audible? Okay. Okay. So am audible now. So today we are going to start properties of fluid. It's a very large chapter. It contains lot of topics. So we will try to minimize the content and explain in a minimal way so that you can understand the topic and concept as well, along with the practice questions. So let's start. Okay. So the brief list of the topics is here. So let's start with our discussion with pressure. So what is pressure? If I say in a single word, everybody knows that pressure thing, I think. So if I talk about, let's consider, okay, one thing is that we are dealing with fluid. In this chapter, we are dealing with fluid. Fluid is something liquid or gas which can flow. Fluid is something which can flow. I think these are the basic definitions that you know. Now, if I talk about, let's consider this is a liquid filled container. It has lot of molecules in it. It has a lot of, like, these are our molecules. I am not drawing all the molecules. There are lot of molecules, but these molecules are randomly moving in different directions. Remember my word, these molecules are moving. So due to this movement, when they strike the surface, they exert some force, and due to this force, the pressure is created. Due to this force, however, the liquid is at rest, but the molecules are moving, so they exert some force on the walls of the container, and this force per unit area is called as pressure. So what is pressure? You can see here, when a liquid or fluid at rest, it exerts a force perpendicular to any surface in contact. That means you can see that this surface is in contact, so it is exerting force perpendicular to it. Exerting force perpendicular to it. Perpendicular to it. This force is exerted by the molecules of the fluid because they are in motion. Now, next thing, how this pressure is defined? Pressure is defined as this perpendicular force per unit area. So, how we can define pressure? Pressure is defined as force which is perpendicular divided by area. So what you can remember, that pressure is not force per unit area, it is perpendicular force per unit area. This force, and this is the symbol of perpendicular. So what you can write, this is perpendicular force. Perpendicular force means the force which is perpendicular to what? Perpendicular to the surface. Is it clear? So from here you can write the unit as well. Unit is force per unit area, that is Newton per meter square. This is again very simple thing. It's clear. Now, one more thing that I will tell you, that the atmosphere in which we are living, it also exerts some pressure. It also exerts some pressure, and this pressure is known as atmospheric pressure. This pressure is known as atmospheric pressure. Anybody knows the value of atmospheric pressure? Anyone? At the sea level, I am talking about. So this is the pressure thing. Now, what are the properties of pressure? Or you can say these are some punchlines. What it is, the first punchline, if I say before drawing, that let's suppose this is a container in which some liquid is filled up to this height. Clear? So, what is the punchline, or what is the special property that in the same horizontal plane, In the same horizontal plane, pressure remains constant. Does it mean this is, let's suppose this is a point A, and in the same horizontal plane, there is a point B. So the pressure at these 2 points will be same. Pressure at these 2 points will be same. This is the basic property. Pressure is uniform in horizontal plane. Is it clear? Second point, if I talk about fluids in equilibrium exert pressure perpendicular to the surface in contact. Like you can see here, the surface in contact with the liquid is this one. This whole surface, this container walls are in contact with the liquid. So the pressure that fluid will exert on it will be perpendicular to the surface, perpendicular to the contact surface, you can say. And the next line that I will tell you, that in equilibrium, the surface of the liquid will remain horizontal. Can you see this surface? However, there is a slight change that we will see, that angle of contact thing we will see later. But in equilibrium, the surface of the liquid remains horizontal. This is another punchline. Free surface of a liquid at rest remains horizontal. I think every point is clear. Now, moving further. Till now, what we have studied, what is pressure? Pressure is perpendicular force per unit area. What are the properties of pressure? The main property of pressure is this one. Pressure is uniform in horizontal plane. Next, variation in pressure with depth. This is again class 10th thing. For example, this is a liquid filled container. This is point A and this is point B. So the separation between them, the height or the distance between these 2 points is, let's suppose, h. One thing that you should remember, that with the increase in depth, the pressure increases. With the increase in depth, the pressure increases. So the pressure difference is given by, or you can say, let's suppose here pressure is P1. Let's suppose pressure is P1 at point A and P2 at point B. So this pressure difference P2 minus P1 will be rho G H. One thing to be remembered, that pressure increases with the depth. Second thing, this rho is the density of liquid. Density of liquid. One more thing that I want to tell you here, that if you want to write the pressure at point A, if you want to write the pressure at point A, only pressure, I am not talking about the difference of these P2 and P1. I am saying that if you want to write the pressure at point A, then how you should write it? Let's suppose this height is something h1. From the free surface, the depth of point A is h1. So at point A, pressure at A is. There is one pressure which is exerted by atmosphere. There is one pressure there which is exerted by atmosphere. So which is P naught. P naught is what? Pressure due to atmosphere. Plus, due to this depth of H1, liquid also exert pressure at point A, which is rho G H1. This is the pressure at point A. If you want to write the total pressure at point A, it is atmospheric pressure plus the pressure exerted due to the depth, which is rho G H1. Is it clear? Similarly, if you want to write pressure at point B, then it will be, there is a pressure, atmospheric pressure P naught plus rho G. What is the depth of point B? This is the depth of point B. Can you say that this is H1 plus H? H1 plus H. This is H. This is H1. So this is how you can write the pressure at any point. I think these points are clear. So what you should remember, pressure difference is rho gh. How to write the pressure? Atmospheric pressure is always there. Moving further. Pascal's law. This is again a very fundamental law. What does it state? It says, look at the definition later. Let's suppose it is a container which is filled with some liquid. There are 2 points in this container. Let's suppose this is point A, this is point B, and let's suppose this is another point C. Each point will have some different pressure because their depth is different. So A, B, C, each point will have different pressure. Now the thing that Pascal's law says, if you add some pressure at any one point, let's suppose I am adding some extra pressure at point B by exerting some force at point A. So if I am exerting some pressure at A, then the same pressure will transfer to all other points in the liquid. That means the same pressure will add in B, same pressure will add in C. Are you getting my point? The pressure is uniformly transferred to the liquid. This is the statement of Pascal's law. What's mentioned here, you can study. The pressure applied at any point in an enclosed fluid is transmitted uniformly to every part of the fluid and to the walls of the container as well. That means if you exert some extra pressure at any point, it will be transferred to each and every point of the liquid as well as the container. Now, one or two more things. Based on the Pascal's law, there are few applications that I think you might know that what are the basic devices that works on this principle. One is your hydraulic brake. The brakes that hydraulic brake are based on this law, Pascal's law, in which oil works as a fluid. Brake oil, that someone of you might know. There is a term as oil brake. Brake oil brake nahi, it's a brake oil. Now next is hydraulic lift is also there, which it also works on Pascal's law. So out of which I am describing hydraulic lift here. This is you can see this is a container kind of thing in which some liquid is filled. It might be some oil thing. It is filled in this liquid, in this container. It has I will say two arms. This is a narrower arm, this is broader arm. What we do, we exert some small force on this side. This is small force. This is small force. Due to which some pressure is added at this point. This pressure is transferred to this side and it exerts another force F dash. If you transfer some pressure, then pressure will be transmitted to the other side as well. And due to this pressure, this car is lifted, or car or whatever heavy thing you want to place here, it's going to be lifted very easily. So by exerting very small amount of force, you can get very large amount of output force. And the ratio is F dash over F is A2 over A1. This is the thing that you should remember. What is F dash? And what is F? F dash is the force on the broader cross section area or the larger cross section area. F is the force at the smaller cross section area. And this ratio F dash over F is A2 over A1. Remember this formula, very useful. Moving further. Archimedes principle. How many of you remember this definition? What is Archimedes principle? In class, I think ninth, you have studied that. I hope so. Is there anyone who remembers this equation? Or in 11th as well, you have studied that. So how many of you remember this principle? No one? Okay. Let's see. One or two things Gauri Lakshmi says, she remembers the equation. She remembers the Archimedes principle. Now listen to me. Let's suppose this body is submerged, or you can say immersed in a liquid container. Now, first thing is this body will displace some water or whatever the liquid is filled in the container. This body, when you dip this body in the liquid, then it will displace some amount of water. So what amount of water will be displaced? I am saying water, and sorry for that, it may be any liquid. Water is in, you know that water is very common thing. So water is coming out of my mind. So don't mind it. What I am saying, the amount of water displaced will be equal to the volume of the immersed part of the body. So first thing is volume of liquid displaced. Is it visible now? Is equals to volume of solid inside the liquid. Now, first of all, tell me this thing. When whatever you can see that when you dip a body, when you dip a body in a liquid, some water comes upward or is displaced. So the amount of water that is being displaced is or should be equals to the volume of the solid inside the liquid. That means this part is inside the liquid. This part is only inserted. So what I'm saying, the liquid that will come out or displace will be equal to the volume of this part of solid. Now, the another thing that Archimedes wants to tell us is whenever you dip a solid in a liquid, then it will exert some upward force, which is known as buoyant force. Which is known as buoyant force. So this buoyant force is given by this Archimedes principle. What it says, the buoyant force exerted on a body which is partially or completely dipped in a fluid is equal to the weight of the fluid displaced by the body. Now, there are a lot of confusing words. First thing is mentioned here that will be used later. Second thing, the buoyant force will act on this in the upward direction. Let's denote it by FB. So this buoyant force will be equal to weight of the fluid displaced by the body. That means the force, or I will write it as force, which force? Buoyant force will be equals to weight of liquid displaced. Weight of liquid displaced. Clear? Now, weight is what? Generally, we know that weight is what? Mass into G is weight. Mass of what? Weight of liquid they are talking about. So mass of liquid into G. This is what buoyant force. Try to understand each and every word. Otherwise, you will get confused. So this buoyant force, again, I am saying mass of the liquid. You know the relation mass is equals to volume into density. Do you know that? What I'm saying, you know that mass is equals to volume into density. Is this the common relation that everybody knows? So I am writing mass of the liquid as volume into density. Volume of the liquid into density of the liquid. Let's suppose it is rho. This is the mass into G. Till now, is there any problem in this? You can tell me, otherwise I will move further. Now, volume of liquid is what? Volume of liquid. Which liquid they are talking about? Read the line. Which liquid they are talking about? The liquid which is displaced. So the displaced liquid, you can say that the volume of liquid displaced is volume of solid inside the liquid. First of all, mark this relation as well. Now I will modify it further because sometimes the relation in this form will be used. So buoyant force will be volume of liquid is what? Volume of solid inside. So I am writing it inside into rho into G. Rho is of liquid and now make a box, a golden box for that. Now every term should be understood. What is the volume inside means? Volume of solid inside the liquid. Baki, rest all the things are mentioned clearly. Rho liquid into G. So both of these relations should be remembered by you. Buoyant force is equals to, what is buoyant force? Buoyant force is equals to weight of the liquid displaced. One thing. And now weight of the liquid displaced is mass into G. Mass of the liquid is volume into rho, and volume of liquid is equals to volume inside the solid, or volume of the solid inside the liquid. I think till now everything is clear. Now I am taking a break of 1 or 2 seconds so that you can grasp this thing and say clearly whether this point is clear or not. This is the most important point. Is this point clear? Say yes or no. Otherwise, I am moving further. Moving further. So if it's clear to you, then solve a question. G is the acceleration due to gravity. Very good. Its value is generally we take it as 10 meter per second square. Yeah, correct. Correct, Chichuni. It's correct. It's acceleration due to gravity. Now, so there is a question on your screen. Try to solve it out. What it says is 700 grams solid cube of side 10 centimeter floats in water. Okay. How much volume of the cube will remain outside the water? Question might seem very small. Let's suppose, first of all, this is a container of whatever in which some liquid is filled. Now, in this liquid, a cube of side 10 centimeter, like something, this is a cube of side 10 centimeter. Side is 10 centimeter. Okay. Density of water is given. Now, tell me one thing. If this liquid, this solid or this cube is immersed in the water or dipped in the water, there will be a buoyant force acting on it. So this is the buoyant force. Is it clear? There must be a buoyant force acting on this liquid, on this block. Next thing is, they are saying that block floats in water. If it is floating in water, what does it mean? that it is neither moving upward nor moving downward. It's at rest. If the block is at rest, then that means the net force on it is zero. So the next force that is being exerted on the block, you can say if there is a block, then gravity always pulls it downward. So there is a weight of the block in the downward direction. And this weight of the block is something m into g, where m is the mass of the block. Till now, everything is clear or not? Now, for equilibrium or flotation, these two forces must be equal. So I can say that buoyant force should be equals to m into g, where m is what? Mass of cube. Clear? Okay. So mass of cube is given as 700 gram. Buoyant force you need to write. What is the buoyant force? I told you that buoyant force is what? I am mentioning here again. Buoyant force is what? Volume of solid inside into density of liquid into G. Is this the same case now? So volume inside, I have mentioned it, volume inside into density of liquid is given as 1000 into G is equals to mass is 700 gram. 700 gram means 0.7 kg. Can I place it? Into G. So G and G will be cancelled. So volume inside is 0.7 divided by 1000. Or you can say 0.7 into 10 raised to the power minus 3. Clear? Meter cube. But when I see the options are in centimeter cube. Options are in centimeter cube. So what you can write it as V inside is equals to 700 centimeter cube. This is the volume inside the liquid. This is the volume inside the liquid. And they are asking how much volume of the cube will remain outside the water. So for outside the water, what I say? Volume outside is equals to total volume minus volume inside. Can I say this? Total volume minus volume inside. Total volume of the solid side is 10 centimeter. So total volume is 1000 minus volume inside is 700. That is 300 centimeter cube. Very good. So what is the volume outside the liquid is 300 centimeter cube, which is option number A. So what's the most important concept that you can learn from this question? The most important concept is whenever the solid is floating. Floating means it's neither moving downward nor moving upward. It's in equilibrium, and for equilibrium, the buoyant force should be equals to its weight. So this is the punchline that you can learn from this question. The concept that you should learn. Rather, all other things are already known, that how to write the buoyant force, how to write the weight, all these things are secondary. Moving further. Now comes, we are moving towards fluid dynamics, in which fluid is moving. So whenever the fluid is moving, the first and foremost equation comes is equation of continuity. Equation of continuity. Before moving to that, I will ask you that what is streamline motion? What is streamline flow? What is streamline flow? You should read it. What is streamline flow? Because all the things that I am explaining here in this section are related to the streamline flow. Are related to the streamline flow. Now, equation of continuity is what? Horizontal movement. Ah, Veena, you can't say like this that streamline flow is a horizontal movement. No, you can't just say that. Read it again, Veena. So what I'm saying, it will take a lot of time if I will explain that streamline flow. Okay, someone has answered again. The movement of water in one direction. Okay, this is somewhat correct, but this is not the only case in this in which you will say that it is streamline flow. But up to certain point, it is correct. Now, let's suppose this is a tube in which water is flowing in a streamline flow. So I will try to explain. Listen to me very carefully. What is the basic purpose of streamline flow? In streamline flow, the water which is flowing do not get intermixed. One thing. This is the flow of water. This is the flow of water. The particle water flow is what? Particles are flowing, molecules are flowing. The particles which are passing through one point always follow the same path. I am talking about the particles which are passing. Let's suppose this is a point A. This is point A. Particles which is passing from point A, if it is going in this direction, then all other particles which are passing from point A will follow the same path. This kind of flow is known as streamline flow, in which each particle follow the path of its previous particle and move in a particular direction. It's not mentioned that they are flowing in a straight line flow. No, it's not mentioned that they are flowing in a horizontal direction. No, they must follow the same path. If one particle is going in upward direction, then the particle which is following this particle will also move in this direction. This is known as streamline flow. Okay. So what is it? In streamline flow, let's suppose the cross section area of one end is A1 and another end is A2. So A1 and A2 are the cross section areas, and velocity of the fluid is V1 and V2 respectively in these two ends. So what is equation of continuity? It says A into V is constant. Area into velocity, the product of area and velocity is a constant, or you can say A1 V1 is equals to A2 V2. Very important relation. Now listen to me again. What I am saying, can you say that velocity is reciprocal to area? From this, the conclusion which can be drawn is velocity is reciprocal to area. And if velocity is reciprocal to area, that means out of V1 and V2, which velocity should be greater? Out of V1 and V2, from the diagram, you can say which velocity should be greater. Can anyone answer? Everyone is saying V2 is greater. Very good. Very good, Gauri. Very good, Veena. V2 is greater because area is smaller, so V2 will be greater. That's the one thing that we can learn. That means smaller the cross section area, higher or faster will be the velocity. Next thing that you can learn from this product A into V. This product A into V is called as rate of flow. Remember my word. Question may ask you calculate rate of flow. So you might get confused. What is rate of flow? Rate of flow is nothing but product of area and velocity. That is A into V is called as rate of flow. I think this slide is clear. Moving further. This is Bernoulli's theorem. What it says, again, let's suppose At this point, pressure, let's suppose P1, at this point, pressure is P2. Here, area is A1, area is A2. Velocity is V1, velocity is V2. The height of the tube at this point is H1 and at this point is H2. So what is the Bernoulli's theorem statement? What it says, for streamline flow, they start with the streamline flow. The sum of pressure energy, kinetic energy, and potential energy is constant throughout the tube. Throughout the tube, if you take any point, any cross section area, let's suppose this is cross section area 1, this is cross section area 2, you can take any other cross section area 3 as well. So for any of these cross section areas, the sum of these energy is conserved, is constant. What is this energy? This is pressure energy. This is kinetic energy. This is potential energy. And for any cross section, it is constant. It is mentioned here as well. In streamline flow of ideal fluid, the sum of the pressure energy, kinetic energy, and potential energy per unit volume remains conserved. Is this point clear? Now, listen to me again. One more thing that I will explain here. Take a screenshot. I will delete this pressure energy term to make some space. Okay. Now, if I say that tube, let's suppose tube is horizontal. Let's suppose tube is horizontal. Horizontal tube means like something this one. So the average height from the ground is same. This is ground and average height from the ground is same. That is H same. It's a horizontal tube. That means potential energy of both the sides will be same. That means at this cross section area, potential energy is rho gh, and at this cross section area, potential energy is rho gh. That means potential energy is going to be same. So both sides potential energy will be same. So what you can say here, it will be cancelled, and what will become P plus half rho V square is equals to constant. Remember very carefully now. This is pressure energy. This is kinetic energy. What if I say the sum of these two quantities is constant? Sum of these two quantities is constant if I say, and again if I am saying that if pressure is increasing, then can you say that velocity will decrease? If the sum is going to be constant, then what if I say that pressure is increasing, that means velocity will be decreasing. Is it clear? If pressure increases, velocity decreases. Now, answer one question. Let's suppose here pressure is P1 and here pressure is P2. Okay, why is kinetic energy and potential energy present? Chichuni is asking. So Chichuni, listen. Why potential energy is present? Because the water or liquid which is flowing is at a certain height from the ground. So due to the mass of the water, there will be a certain potential energy. Certain potential energy. Because it is at a certain height from the ground level. Now, why there is a kinetic energy? Because liquid is flowing. If it is flowing, that means it has some velocity. If it has some velocity, it has some mass, then there will be some form of kinetic energy as well. Are you getting my point? if it has some mass and velocity, then there will be some kinetic energy as well. So that's why it is mentioned. Okay. So what I'm saying, this is pressure P1, this is pressure P2. At which point pressure will be more? You want to write the relation between P1 and P2, which is greater? Out of P1 and P2, which is greater? Think about it and answer. Is the question visible to you? Is the question visible to you? However, it is drawn in a very small space. Okay. Uh, Pradiksha is saying P2 is greater. Okay. Ayushi is also saying P2 is greater. Chichuni is also saying P2 is greater. So I think everyone is saying P2 is greater. Okay. So let's find out. Okay. Pridarshani is also going with P2. Everyone is saying P2 is greater. So everyone is saying like this. This is now. Okay. Now listen. What I am saying, if velocity is less, then pressure will be more. How can you say that? From the continuity equation, we have seen that lesser the area, larger the velocity. That's what we have seen now. Lesser the area, larger the velocity. That means if velocity here is v1 and velocity here is v2, so you can clearly say that v2 is greater than v1. Can you say this? Say yes or no. Can you say this? Velocity v2 is greater than v1. Narrower the part, narrower the area, higher the velocity. So v2 is greater than v1. When velocity increases, pressure decreases. When velocity increases, pressure decreases. That means v2 is more, then p2 will be less. Okay. P2 will be less. Are you getting my point? Can you realize what you made wrong in your solution, in your answer? And everyone was doing the same mistake. Okay, listen again. V2 will be more. You are clear with that? V2 is more. Why V2 is more? Because area is smaller. If area is smaller, then velocity is higher. Clear. Now, if velocity is higher, then pressure will be less. So P2 will be smaller than P1. So what you can remember, ultimately what you can remember, if pressure increases, velocity decreases, or in other terms, if velocity increases, pressure decreases. That's why you can see that क्या बोलते हैं उसको, बहुत तेज हवा जब चलती है उसको क्या बोलते हैं? वी कॉल इट एज आंधी. व्हाट वी कॉल इट एज आंधी आई. आंधी आई है ना. So what I'm saying, in whenever there is wind is blowing actually very fast, and the teen shade, you know that teen shade, they just blown away. Why they blow away? If I can draw a teen shade for you, like this is a wall, this is a teen shade. If I can draw, I don't know whether I will be able to draw it or not. Let's suppose this is a teen shade. You can imagine that this is a teen shade. Okay. Wind is something blowing at a very high speed, and below the teen, or in the room, there is no wind, or kind of no such wind is there inside the room. There is high velocity. If there is high velocity wind is blowing, that means pressure here decreases, and there is no wind below the teen shade, so pressure remains same. pressure remains same as it was earlier. So if pressure decreases at this above level, so this is a tin shade. At this side, at the above side, pressure decreases. So this below pressure is just exert some extra pressure because there is a pressure difference and this tin shade is blown away. So what you can remember that if velocity is more than pressure decreases. Clear? Okay. Uses of Bernoulli's theorem. There are a lot of uses of Bernoulli's theorem. Like there is a Venturi tube. There are the aeroplanes. Aerodynamics are also designed on Bernoulli's theorem. One is I am telling you the tin shade. Magnus effect is also on Bernoulli's theorem. The spinner that who balls the ball and it spins reverse swing. If you see cricket there, the banana kick of the football is also based on Magnus effect, which is further based on Bernoulli's theorem. So there are a lot of phenomena which are based on Bernoulli's theorem. Out of which this is very common, speed of efflux, from which numerical may be asked. That's why I have placed it. Velocity of efflux is V is equals to root 2gh. What it is, listen, this is a container. This is a container. In this container, from the free end, mark my word, from the free end, or if I say free surface, at a height h or at a depth h, there is a hole. There is a hole from which liquid is coming out. So the liquid, the velocity of the liquid which is coming out is given by root 2gh, where h is the depth from the free surface. Mark my word, total height of the container is not used, but the height of the hole from the free surface is used. V is equals to root 2gh. Now there is a question. Answer this question. I am waiting for your response. And you must answer this question. If fluid is in streamline flow across a horizontal pipe, mark the sentence horizontal pipe of variable area of cross section. For this, which of the following statement is correct? It's not multi-correct, it's only single option is correct. First option says, read out the options and answer. First of all, they are talking about okay, Veena is saying option A, Chichuni is also saying option 1. Anyone else? Pradikya. I think this is the same question that I was explaining now. This is the same question. Is it? Very good. So the question says the velocity is maximum at the narrowest part. That's very true. At the narrowest part, velocity will be maximum. And pressure is maximum at the widest part of the pipe. Pressure is maximum at the widest part of the pipe. So this option is correct. We have discussed it right now. Moving further. Now, a small hole of area, some 2 mm square, is present near the bottom of a fully filled tank. Taking G as this much, rate of flow of water. They are asking the rate of flow of water. So what is rate of flow? What is rate of flow? You know that now? I have told you what is rate of flow. A into V, very good. So this is a container in which water is filled up to a height. Tell me up to what height water is filled. This is filled up to 2 meters. Clear? And a small hole of cross section area, something, there is a small hole here. I can't make it. So there is a small hole from which water is coming. Okay, let's velocity of this water coming is v. Clear? So what will be the velocity? We know that velocity is equals to root 2g h. Clear? This is the velocity. So if I place the values, or I am directly placing root 2g is 10, h is also 2. So it will be 2 root 10. And anybody knows the value of root 10? Anyone who knows the value of root 10? So rate of flow is equals to A into V. From this whole volume or liquid is coming out. So the rate of flow will be area of this hole is 2 mm square. That is 2 into 10 raised to the power minus 6. Clear? Mm square is converted into meter. Into velocity is 2 root 10. 2 root 10. If you solve this, you will get the answer. If you solve this, you will get the answer because root 10 is asked. So I will say root 10 is something more than 3. Root 10 is something more than 3. 3.16. Ayushi is saying root 10 is 3.16. So if I place the values here, it will become 4 into root 10 is 3.16 into 10 raised to the power minus 6. So it will be 12.6 into 10 raised to the power minus 6, which is option number B. Option number B. Very good. Clear? Moving further. Surface tension. This is again a very important concept of surface tension. Question are asked from this. What is it? First of all, see some image. Look at this image. A paper clip, I think it's a paper clip. The paper clip is placed at the surface of the liquid, or you can say surface of the water. If it is placed at the surface of the water, it means that water, the surface of water is behaving like, you can say, it is exerting some force. It is exerting some force. Another image you can see, mosquitoes can just can just sit over the surface of water and they can flow, they can swim like that without sinking in the water. And look at that. The drops are spherical in nature. Generally, the drops are spherical nature. All these phenomena come to an end, which says the surface of a liquid tries to minimize its area, and this property is known as surface tension. What is surface tension? The property of liquid surface due to which it tries to minimize its surface area is called surface tension. So there is a lot of physics behind this phenomena. Why it is trying to minimize its surface area? It's a detailed topic. It involves some energy concept, but right now you can remember that property of the liquid due to which it tries to minimize its area is called surface tension. Moving further. What is surface tension? How it is calculated? Let's suppose the water which was filled in the glass, the top view of the surface is this one. Top view of the surface is this one. Before moving to that, I will explain you one more thing here, that if this is a container, in this container up to this height, water is filled. Then this water or this liquid can be broken in two parts. One part which is near the surface and one part which is below the surface. So this above part of few molecular distances, this is generally known as surface. and this part is known as bulk of the liquid. The behavior of the bulk is different than the behavior of the surface. Mark my words. Behavior of the bulk part of the liquid is completely different from the surface. Surface shows some different phenomena, out of which one phenomena is surface tension. What is liquid surface? The surface, the distance from the top layer up to few molecular distances is called surface, and the behavior of two is different. Now, what I am talking about, let's suppose this is the surface, front view, top view of the surface. Now, I have divided the surface in two parts. Let's suppose the length of this is L. Length of this is L. The surface tries to minimize its area. Can you imagine it with a uh, cloth of stretchable material? Or you can say, take a rubber kind of material, that's a balloon kind of material, and if you stretch it, it has a tendency to shrink. It has a tendency to shrink. And if it is shrinking, what it do? These are two parts. This is one part, this is two part of the surface. I have divided the surface in two parts. Each part will try to pull the other part by exerting some force. Part one is pulling part two, and part two is pulling part one. So the surface tension is defined as T is equals to force per unit length. P is equals to force per unit length. Now, unit, if I say, that will be Newton per meter. But out of this context, the surface tension is not very important to calculate. That important thing to calculate is force exerted due to the surface tension. So force will be surface tension into L. T is what? Surface tension. Now, again, moving further. One more formula that you can remember. After that, we will do two questions and complete the session. Surface energy. Surface energy is what? The energy that is stored is it surface tension into delta A effective. Now, again, one thing that is very important to understand, what is delta A effective. Let's take an example. Let's suppose this is a wire. Remember my word. This is a wire, or you can say this is a loop. Clear? This is a loop. Now, if you dip this loop in a soap solution, that in your childhood, I think most of us play with those things. If you dip this in the soap solution, what you will get? You will get there is a thin film in this portion. You will find it. And if you blow it, some soap bubbles are blown. Kind of play a game that children play usually in their childhood. I have not played like that. Okay, in my childhood. So this is the film, liquid film, or this is known as soap film. This is known as soap film. So what is the meaning of effective area? You can clearly see that if this is the soap film that is formed in this wire, so one side is from the front and once you can see from the back side as well. So you can see two surfaces from in this loop. One is from the front, one is from the back. So area effective is due to both the surfaces. Area effective is due to both the surfaces. Clear? Similarly, one more thing, if I say, if there is a liquid drop, and there is a soap bubble. What is the difference in them? So liquid drop has liquid inside it. This is liquid. So there is only one surface. Soap bubble has air inside and air outside. So it has two surfaces. So what I'm saying, soap bubble has two surfaces. Liquid drop has one surfaces or one surface. This soap film has two surfaces. Remember these things. These are very important things. Now, one question we will take. Question says, a thin liquid film is formed between a U-shaped wire. This is a U-shaped wire and a light slider. This is the slider. Okay. So liquid film is formed like this. This is the liquid film. Again, they are saying which supports a weight of 1.5 from this slider. A weight is supported. Weight is how much? 1.5 into 10 raised to the power minus 2 Newton weight is supported. The length of the slider is 30 centimeter. Very good. Find the surface tension of the liquid film. Okay. One thing that I am saying, liquid surface will try to shrink. So it will try to shrink. It will exert force F. But there are not only one surface, there are two surfaces. So both the surfaces will exert force on the slider. Both the surfaces will exert force on the slider. Clear? Or you can say 2F is equals to, this upward force is equals to 1.5 into 10 to the power minus 2, because it supports. Supports means balance, equilibrium. And we know that force is equals to T into L is equals to 1.5 into 10 raised to the power minus 2. Now, if I calculate this, 2 surface tension is asked, length is 0.3 meter is equals to 1.5 into 10 raised to the power minus 2. This will be 6. 15 by 6 means 2.5 into 10 raised to the power minus 2 Newton per meter. What's more important here to learn why 2F is used? Because there are two surfaces. Each surface will exert a force F, then two surfaces will exert a force 2F. Is this question clear? Solve this question as a homework. And I will see you in the next class. Till then, bye everyone. For droplet, how to calculate? Okay. Okay, if you have time, I will solve this question for you. Calculate the gain in surface energy. First of all, you should remember the formula for surface energy. That is surface tension into change in area or effective change in area. Clear? So now come back to the question. Question says there is a one large drop of radius r. It is broken into 1,000 equal droplets. Let's suppose these are 1,000. I can't draw 1,000. So I am drawing only 6 droplets. These are 1,000. Let's suppose radius of each droplet is small r. Clear? So they are saying that change in energy. So change in energy is equals to surface tension into change in area. Now change in area is what? Area final minus area initial. So we need to calculate the final area and initial area. Can you say this is the final situation and this is the initial situation? Is it clear? Now again, if I say, if this is the final situation, radius is r. So for calculation of area, I need this radius small r. Is it clear now? Now listen. Can you say that 1,000 droplets are made using this one large drop? That means water content will remain same. That means volume of water will remain same. So volume here is 4 by 3 pi capital R cube is equals to 4 by 3 pi small r cube. But this is the volume of one drop. How many drops are there? 1,000 drops are there. Is this statement clear? From this statement, you can get 4 by 3 pi, 4 by 3 pi cancelled. So small r will be r by 10. Is it clear? Small r cube will be capital R cube by 1,000. So small r will be r by 10. So we have calculated the radius of this part. Now I am going to calculate initial area and final area. Initial area, this is a spherical drop. Area is 4 pi r square. No problem with that. 4 pi r square is the radius. R square is the radius. Final area, 4 pi small r square. This is the area of one drop. How many drops are there? 1,000 drops are there. Now put the value of small r. 1,000 into 4 pi. Small r is about r square by 100. 2020. That means final area is 40 pi r square. Is it clear? Now place this in this equation. What you will get, delta U is equals to surface tension is T. Final area is 40 pi r square minus 4 pi r square. It will be, I think, 36 pi r square T. This is what delta U. Is this question clear? This is again a very important question. Okay. So I think now we should end the class. Okay. Bye everyone.